My recent work on the Bluetooth amplifier module, well, Bluetooth power bank thing, made me think about this and this awkward eye-shaped malfunction here that comes from not driving these hard enough and also having the filament at DC. And I thought I'd just take half an hour and roll a new version of this main board. Make everything a little less complicated, and also how this works is, yes, this is a snap fit, but I had it off so often that now it's not a snap fit anymore. This works by just having a big cob LED on a brass on a rectangular piece of sheet metal, really, as a heatsink. And I thought, I'm not running this LED at its full 20 watt power anyway, I'm running it at 10 watts. I could just as well use those smaller LEDs, those are I think 2 watts each, and just have 4 or 5 of them, and put them on a PCB like this, but this doesn't have the exposed copper yet. And also it doesn't have any heatsink pads, which I definitely should add. This was just a proof of concept really. I'll sort this up later. And then just have them stacked on top of each other, which would make assembly and everything a lot easier. If I ever do a small production run of these, then you could just order 2 PCBs, maybe one aluminium backed, and then just have a couple drilled holes on there that are specified, but didn't drill out on this board because it doesn't need it, it's prototype. And then just bolt them together with standoffs. And so this is one of the things I did, was sort of optimize the design in that direction. What I also did is, this version that is in here has a couple discrete transistors in this place to drive everything, to drive the VFD. While this has the ULN 2003, and this also, it has the multivibrator circuit that I talked about last time on there. And for routing reasons, on this prototype I powered this from the 20 volt rail, which turned out to be a really bad idea. I thought I could just sort of up the resistors here a little, and then this would work fine. But it turns out if I increase this resistor here to about 500 ohms, which I calculated it has to have for this to work properly, then it just won't start oscillating, because the resistance of the cold filament, this is what I suppose it does, the resistance of the cold filament just damps this down, and I just made it stop oscillating. So this doesn't work all that great in this configuration yet. And the other thing is, this doesn't have a switch, so how I actually turn this off and on is you have to desolder the battery. It's a little bit annoying. Suppose I could just use a crocodile clip. Just clip it on and see if it starts back up. No, it does. Oh, I see what I did. Oh, yeah. Yeah, this design has some problems. So the issue with that is, you can't see that on camera, but what happens is I touched this down here, and it was so hot that the solder was already molten, so I just sort of shoved the transistor off to the side. And now obviously the circuit doesn't work anymore because the resistor is missing. So yeah, this design has some issues still. So what I want to do is, instead of powering this from the 20 volt rail, which is obviously a bad idea, I'd much rather power it from the 5 volt rail. Because the other thing is the current draw of this running, I can't show it to you anymore because now it's not working. Or maybe I'll take the time and fix it. So I just stuck the resistors back on here, and they just, as soon as they make contact, they refloat in place because the solder was melting from the resistor getting so hot from being overloaded. And you can actually see down here on the board, the board is getting a little dark around the resistors because they're just getting so hot. So this obviously doesn't work and has to be fixed for multiple reasons. One of them being this probably runs for half an hour and then burns up. The other thing being with the solder being molten, every time you turn around your flashlight, all your resistors will fall off. It's not great. The other reason why I think this doesn't work all that well is the filament is supposed to take about 35 milliamps, and each of the segments runs under a milliamp each. But if we look at the actual current draw, this draws about an amp, which is just fantastically inefficient. I mean, it's probably, it would get a little bit better once you add in the LEDs, because the boost converter would run more efficiently, but this is not great. It's not supposed to draw an amp from this battery. We have to get that down a lot further. And one of the things that I thought about was maybe running the multivibrator directly off the battery, because the filament only takes about 2 volts. So what I'm currently doing, which is a little bit insane, is stepping the 3.6 volts up to 20 volts, then getting it down to, well, about 5 volts, then passing it through this resistor, and then passing it through. And the other thing I could do is actually run this off the 5 volt rail, and then I wouldn't have to burn so much power in this, but it would actually not change all that much about the current draw on the 20 volt rail, because the 5 volt regulator is linear. So the best thing would probably to run this off of the battery, and I'll modify this breadboard circuit here and just see if that works. I went back to the drawing board on this, and I'm back now at the original circuit, which is a multivibrator feeding into a double half H bridge L911O-H over here. But now, instead of being connected to 12 volt, this is actually connected to the 3 volt from the battery. And the current draw is pretty acceptable now. It's at 300 milliamps. That's about 1/10 of the current draw when the thing is on, so I call that just about acceptable. I mean, it's still not great, but it's definitely better than drawing an amp. And the display looks really nice now too. I might get the current draw down by swapping out the resistors a bit and just optimizing it slightly. Although I don't think that we get much on the 200 milliamps. It's a bit of a shame, but yeah, I guess it will do for this prototype board. There's unfortunately not much hope for actually making this work. I have to sort of redesign the whole circuit and put this H bridge in. But I'll do that. I have some space on this board left. in which to do that. And yeah, then this weird display anomaly will be fixed, and the whole thing will be a bit easier to assemble and to use. So after that first prototype being a bit of a disaster, I actually designed another board where I put the L9 110H, I think it is, the H-bridge chip on the thing, and this is now driving the VFD. And also it's all running from the 3.6 volts of the battery, which saves a lot of current. I actually also fiddled with the resistors a bit, and now this, in idle without the LEDs, actually draws 250 milliamps of current, which is alright. And I also have really nice and even illumination across this, even if I go down with the exposure. This is still very nice. So this works even with the added complexity of having a double half H-bridge driver down here. Oh, it still fits on the board nicely. And one other change I did is I put a diode down here by this charger chip to lift the ground up by 0.6 volts. Because I don't know why it does that, but this charger chip, it only charges to 4.05 volts, which is way too low. You're wasting battery capacity. So I just bumped it up a little, and now it charges it to about 4.1-ish, and that should give some more battery life, even though it's pushing the batteries a bit harder, but it's recycled laptop cells anyway, so I don't care too much about that. Yeah, also have the ULN 2003 driver on here. This works just fine. At the moment it's fully charged, and you can't actually see anything, especially because the chip is calibrated to the voltage level that this has under load, so this is lit up all the way. Even if the battery were at 50% charge, it still would not display that, because it's missing that load. And what I also did is I designed another board that just stacks on top of this, and it just has a couple of LEDs on there that don't have thermal pads yet. There's a prototype. Might even do this in aluminium back PCB or something like that. Yeah, well, I'll put this all together, and then we'll have ourselves a new battery-powered torch. So I have this all together now, and as you can see, display is much nicer than on the other version. Still have the USB port on the back. The charging works alright, and I have the prototype LED array here in front. It's just hold on with a single standoff. The only thing I have to do is I have to reprogram the chip, because this is a different load. It's a little lower powered. The battery gauge doesn't work, because this is actually, it's not all the way charged. It actually should have the first section off. But yeah, I can just unscrew this, pull the chip out, put it in my programming fixture. I also have to make up one of those covers like this. I'll just try and put this on here, although it's probably going to be, yeah, it's a little tight. I changed the overall dimensions of this just by a millimeter. And now this doesn't fit anymore, so I have to print a new one. But yeah, this looks very nice. It's a very useful torch.